In this video, we'll cover independent and dependent variables and how they're used in curve fitting. In curve fitting, the independent variable is the x-axis or horizontal axis data. This is the input or predictor that you control or choose, the explanatory data. The dependent variable is the y-axis or vertical axis data. This is the output or response that you measure or observe. These two variables are essentially cause and effect data, the independent variable constituting the cause and the dependent variable the result. Let's work through an example. I want to create a curve to determine if there's a relationship between two variables. In this case, I'd like to see if there's a relationship between the amount of water I give my plants and the height they grow. So I've performed an experiment where I water my plants with varying amounts of water each week. One plant receiving 1 unit of water, the next plant receiving 2 units, the third 3 units, etc. And I've measured the height of each plant after 3 weeks. And you can see my data in this table here. First, we'll need to identify which variable is our independent variable and which is our dependent variable. The independent variable, or x-axis data, is the variable that I've controlled. In this case, it's the amount of water I gave the plants each day. The dependent variable, or y-axis data, is the variable I measure or observe. So in this case, that's the growth of the plants, measured in centimeters. The growth of the plant depends upon the amount of water provided. Let's try to quantify this relationship. I'll navigate to mycurvefit.com and log in to my free account. I have some data for this scenario in an Excel spreadsheet. So I'll copy that data with water in units being my x-axis data and plant growth being my y-axis data. I'll clear the data from mycurvefit.com and paste in my measurement data. I'll move through the steps of the import wizard to identify how my data is organized, and press apply to apply the changes. I'll update the axes titles to water in units for the x-axis and growth in centimeters for the y-axis. This looks like a linear relationship, so I'll set the fit method to linear regression. My curve fit equation is y equals mx plus c, where m equals the slope and c is the y-intercept. The curve equation for our fit is y equals 1.5x plus 0.5. This suggests that with each additional unit of water, the plant will grow another 1.5 centimeters. There appears to be a strong linear relation with this data, so we could use this model to predict or interpolate values. For more information on linear predictions, please see the associated video. In our plant example, it's pretty easy to identify the variable under our control, the independent variable, and the variable we're measuring, the dependent variable. But what about a case where it's not as obvious? Let's say we have some data we've been looking at, the high temperature outside for that day, and the number of ice cream sales made. It looks like as the temperature increases, so do the number of sales, but I'd like to try to quantify that relationship to determine if there's a correlation. So which variable would I plot on each axis? Here we're observing but not controlling the temperature, but based on what we've observed, it seems the temperature is a predictor of the number of ice cream sales. So because the predictor data is the independent variable, we would plot the temperature on the x-axis and the number of sales on the y-axis to generate a model for sales predictions in the future. Let's quickly add this data to mycurvefit.com. I'll clear out the data used in our previous example and copy and paste in our ice cream sales data. I'll update the x-axis title to be temperature and the y-axis title to be ice cream sales. So you can see it does appear to show a relationship between the temperature and ice cream sales. However, I'm not convinced that a linear regression is the best method for this data set. Let's try a 4PL fit. And you can see here this appears to be a good model for further predictions and calculations. An example application for this model might be to use local weather forecasts to plan the stock of ice cream required. If you have any questions about independent or dependent variables in curve fitting, please email us at support@myassays.com.